Hello everyone. Today I'm starting Unit 5 of Science Learner Book, Cambridge, for Grade 3. Let's start Forces and Magnets. Lesson 5.1 Forces and Force Meters for measure the force. In this lesson, you're going to learn about how to measure forces using a force meter, measure using standard units. What are the units we are using to measure force? So let's start. Forces are pushed, push and pull. In simple words, what are the forces? Push and pull. When you're pushing something to change the position of any object or pulling something to open the door, you're using your force. Look at the children on this roller coaster. Talk with a friend about the forces you might feel at a fairground. Forces can make things happen. Obviously, when you're applying your force on something, or different kind of forces. So happening what? Different kinds of things. Write down some different types of changes that happen because of forces. Everything mostly you can say with the help of force you can do it. Or with the help of forces, different things change their positions. Okay, there are some vocabulary word in this lesson. Force meter, Newton, non-standard units, gravity, standard unit and weight. We discussed in this lesson about these vocabulary words. There are three scientists, John Philoponus and Ibn Sina and Isaac Newton. Our understanding of forces was different in the past. Here are the three scientists who changed the science of forces. What about the first from Egypt, from the time period from 490 to 580? Okay, Philoponus wrote that objects move because making them move gives them a force. And what about Ibn Sina? Ibn Sina worked out that forces can make objects move. For example, if you are touching or putting your force on some kind of object, so obviously it's not stay on that place. It move from one place to another place. It's another thing which for kind of force you're using and how much force you are using. Newton found out that forces can make objects speed up, like a ball. It's moving. So you put your force, it's more moving faster. Or slow down, or change direction. Obviously, if something is coming and you put your hand in front of it or your foot, so it's maybe slow down or change the direction. You apply your force. Scientists now know lots about forces. Forces can make some objects change shape. Yeah, you're applying the force on rubber. You can stretch it. You can bend an iron. You can compress like some kind of balloon if you're applying the force. They can make objects speed up, slow down, or change direction. Jamieson, Maya Jamieson was a scientist who investigates forces in space. Obviously, on the Earth, like Earth, it's have a gravity and it's attracting all the things downward. You're applying the force. So, so gravity is the force that pull objects toward the Earth. Gravity makes object have weight. For example, if your weight on the Earth is about 40 or 50 kg, on the space it's not same like this because on the Earth it has gravity and pulling you downward, but on the space there is no gravity, so your weight less than on as compared to on the Earth. Weight is another force you can measure. There is an experiment. Make a simple force meter to check how much force you are applying. You will need a rubber band, two plastic paper, a piece of cardboard, glue, and a piece of lined paper. What you need to do, a force meter is a piece of equipment We are using force meter to find the force, how much force we are applying to pushing or pulling an object. Here we just uh, for 4 meter we just put, or you can say hang the object and then leave it. Then we can see how much force need this kind of equipment or this kind of thing, how much force it need. It's measuring by a force meter. A force meter is a piece of equipment we use to measure the strength of a force. Zara has made a simple force meter. This is same like this, a force meter shape. Just simple, you need a what? Take a cardboard, write 0, 1, simple with the little distance. Same like this, as you can see, and then put a clip and rubber band and another clip, two clips you're using, and a rubber band inside. So this is a simple force meter you can make at your home. Make a force meter like this. Mark the end of the rubber band. Label this 0, starting from 0. Obviously, starting from 0. Okay, and then number each line below the 0 mark. Use your force meter to measure some forces. Okay, now you can measure the force meter force needed to pull things. Obviously, a force of 7 lines is needed to mark this book move. Okay, if you want to move the book, how much force you require, and if you want to uh, pull up a scissor, how much force you require. This scissor have a weight of 8 lines. You can see here. So this scissor have a weight of 8 lines. Measure some different forces and make a table of your own result. Put different thing here, or you can say just hang some different things which can easily hangable, and then you can find how much lines you require, how much line, or you can say how much force you require to catch up or catch the thing or pull these things. After this, for force meter, which kind of unit we are using? Like if I'm buying water, so water we are using a liter or milliliter unit. If something else we are buying, we are using kg, kilogram or gram unit. So what about force? What kind of unit we are using? Standard unit and force meters. Standard unit are useful for measuring. Okay, for meter and centimeter are standard unit of length. Well, I want to find to measure the length or of different things. We are using this as how many centimeter or how many meter, and minutes and seconds are a standard unit of time. After this, standard unit are useful. Why? Because everyone in the world who uses them can compare their measurements. The standard unit of force is a Newton, and capital. This unit is named after the scientist Isaac Isaac Newton. According to his name, Isaac Newton. So you're using the same. His name Newton, like 5 Newton, 10 Newton, 20 Newton. Force required to pull a book or different things. So this unit of is named after the scientist Isaac Newton. This force meter can measure in newtons. Actually, this is the accurate shape of a force meter. Let's start question answer. Let's start question answer. Name of force you can measure. What is the standard unit of force? Obviously, with the force, you can measure the weights. So we can write here weight. What is the standard unit of force? Simple. It's written here. The standard unit of force is the Newton. So I'm just writing. Simple answer. Why? Why are standard units better than non-standard units? There are different answers. The standard unit are better than non-standard unit. Why? Because standard measurements make it easier to compare your measurement with other people's measurement. So that's why you're using standard unit. So, for example, I'm applying the force. It's 10 Newton. Someone applying the force. It's 20 Newton. So for comparison, also it's better. So you can write here. The second activity we have here, make a better force meter. You will need your simple force meter, some plain paper, some glue, and some 100-gram masses. The simple force meter uses lines as a unit of force. It uses a non-standard unit. You can make a better force meter by making it measure in standard unit Newton. On Earth, 100-gram mass has a weight of 1 Newton. So it's been 1 Newton equal to 100 grams. So 10 Newton equal to 1 kg or 1000 grams. So Zara used this force to make her force meter better. So 1 Newton equal to 100 gram. 100 gram. Let's move to the next page. Zara adds a new piece of paper and make the zero line. Then she hang a 100-gram mass on her force meter and make the 1 Newton. So you can see here as she's hanging the 100-gram force meter. This then she add another 100-gram mass and make mark the 2 Newton lines. She mark halfway between each line so she can measure. You can see here this is a 0, 1 Newton, 2 Newtons. Same like this. So we are measuring. Actually, when we are making measurement or this force meter, we should mention this is 0, 1 Newton, 2 Newton according to 100 grams. No need more than 5 or 4. It's enough for you. Make your force meter measure in newtons, then use it to measure different some forces. Make a bar chart to show your result. Like this, we complete our lesson 5.1. In the next video, we will start 5.2.